Hello and welcome to Chemistry Masters. So in today's video we are going to discuss about the pi molecular orbital formation of allyl systems. So here we will be discussing three type of allyl system: allyl cations, allyl anions and allyl radicals. In this video the details of formation of the molecular orbitals from atomic orbital will be discussed, along with the formation of nodes, that how the nodes are being generated. So let us move forward. In the previous two videos, we have discussed about the formation of pi molecular orbital of ethene and pi molecular orbital of 1, 3 butadiene. So today we will be discussing about the pi molecular orbital formation for allyl system. Before understanding the formation of pi molecular orbital for allyl systems, we should be knowing that what allyl molecules are. So allyl molecules are such molecule in which there is presence of a charge or maybe free radical in conjugation with a double bond, or you can say with the unsaturation. So if you see, generally these allyl system are of three kind: allyl cation, allyl anion and allyl radical. These structures are shown here. The A is your allyl cation, B is your allyl anion and C is allyl radical. So in all of them you can see either there is a charge, maybe positive or negative, or there is presence of a radical in conjugation with a double bond. That's why we call them as the allyl system. In all these allyl system, if you remember our earlier videos, there we have discussed that all those atomic orbital which are associated with double bond, they are responsible for formation of pi molecular orbital for any molecule which is undergoing pericyclic reaction. Not only this, the molecules in which there is presence of charge along with the double bond, or you can say along with the unsaturation, that can also be taken in the consideration for the formation of pi molecular orbitals. That's why in allyl, overall there will be three carbons whose atomic orbital will be undergoing the combination for the formation of molecular orbital. So if you talk about A, B and C, in all of them you can say there is a double bond in which there is association or there is presence of a charge or a radical in conjugation with this double bond. That's why all three carbons and their atomic orbital will be responsible for the formation of molecular orbital in these. Now let us discuss that how the molecular orbital will form and what will be their total number. So if you talk about molecular orbital of allyl system, you can consider this allyl molecule as a ethene molecule getting associated with one other orbital or atomic orbital like this. So this is your orbital of ethene and this is the orbital or atomic orbital for a cation, maybe anion or maybe radical also. So there will be combination or there will be overlapping of these orbitals to give you molecular orbital. Now we all know that the number of atomic orbitals which are there, they always give you bonding and anti-bonding molecular orbital. So whenever they will join in such a fashion that one of the species or one of the molecular orbital which will be obtained to you, it will be of bonding nature like this, as we have shown here. In this, what will happen, this ethene orbital along with this single orbital which has been shown here, which could be of cation, anion or radical, they will be joined in such a way, or they will overlap in such a way that they all will be facing, or their lobes will be facing towards same side. So in this you can see there is bonding and here also there is a bonding overlap. That's why this is considered to be as the bonding molecular orbital. And as you can see, there is no anti-bonding between the orbitals, or there is no destructive overlap between the orbital. That's why its energy will be minimum. The another way by which they can be combined could be like this, that these two orbitals of ethene could be present on the same side, but this orbital of your cation, anion or radical could be arranged in opposite direction like this. Okay, so when this will happen, in that case what will happen, you can see one of the overlap is of constructive type, that is bonding type, another one is of anti-bonding type, or maybe you can say destructive overlap. So if you talk about these two, so this one which is at the lower end, which can be also called as psi1, will be having less energy, while this one which is considered to be psi2 will be having higher energy as compared to psi1. And that is only due to the presence of this anti-bonding orbital, which cancel out the wave function of this bonding orbital. Now there could be some other arrangement also. Now this can also happen, that this ethene orbital which we have shown to be symmetric, it could be like this also, where the two orbital could be present in opposite direction. Now here also what can happen, this ethene molecule where the attachment is of opposite kind can get joined to this orbital of your cation, anion or radical. And the first addition could be like that, these two are in opposite direction, and this could be also opposite to what we have shown here like this. So this orbital of ethene, or the first atomic orbital of this ethene, is this one, second one is shown here, and this third one, that is your single atomic orbital out here, it is shown in opposite way, so that you can see this is anti-bonding type of orbital and this one is bonding orbital. Here you can consider it as psi3 at this time. Now the last type of overlapping or last type of arrangement which could be present here would be a case that these two orbitals, the molecular orbital of ethene and atomic orbital of cation, anion or radical, could be arranged in such a way that all of the orbitals, they will be overlapped in destructive way, somewhat like this. Now if you see in this case what we have shown, that these two orbitals of ethene, they are as they are already here, and this is also in the same way as it is present here in this atomic orbital. So this is your anti-bonding orbital, this is also your anti-bonding orbital, because they are of different kind. So at this time you can call it as psi4, and the energy of this anti-bonding orbital would be highest and its stability will be least. Now if you see, out of these four orbitals which we have formed here, two of them are of same kind, that is psi2 for the instant and psi3 which is shown here. These two are of same kind. As you can see, in both of them there is one bonding overlap and one anti-bonding overlap. So whenever this condition happens, we can consider them as same. Actually the energy of these two orbitals is of same kind, so you can consider them as one, and actually they are shown in some other way which is being shown out here. So this is your psi1 which is having all the bonding orbitals or bonding overlap. This is your psi3, this is your having anti-bonding overlapping, while this is your psi2 which is actually the combination of those two orbitals which we have shown earlier. Now one more concept which we already know, that whenever the atomic orbital joins to each other, they make molecular orbital. And the another thing which is very much important, we already know that the number of atomic orbital is always equal to the number of molecular orbital. That means, so in this particular molecular orbital, as you can see, there are 3 atomic orbitals, 2 of ethene and 1 of this cation, anion or radical. That means there should be only 3 molecular orbital. That's why these 2 can be considered to be as 1. Actually, the energy of this second molecular orbital and energy of this third molecular orbital is same. That's why these 3 molecular orbital are formed. Out of them, the psi1 is considered to be as the bonding molecular orbital. And we all know that the bonding molecular orbital and anti-bonding molecular orbital are of equal number. So if there is 1 bonding orbital, there will be 1 anti-bonding molecular orbital. And this psi2 will be called as the non-bonding orbital. And we all know that anti-bonding orbitals are always shown with a star to tell that they are of anti-bonding nature. Now the next thing which we have to discuss here is about the nodes. Now if you talk about the nodes, we already know that there is a particular formula for that, and that is node equals to energy level minus 1. So let us just have a discussion over the nodes which we have discussed in earlier lecture also. So nodes generally tells you that how does the adjacent orbitals in a particular molecular orbital are arranged. So there are 2 ways by which they can be arranged. The first way could be that in which the 2 adjacent orbitals will be arranged in the same way, means the filled lobe on the upper side and the unfilled lobe on the lower side, or you can say the positive and negative lobe you can show they are on the same side. Then we said that there is no node. While if you talk about the another condition, when the same type of lobes are on the opposite side like this, then we say that there is presence of a node. So how many nodes would be present, that will again depend upon the structure. So if you see these 3 molecular orbitals, psi1, psi2 and psi3 star, so according to the formula, the node equals to energy level, that is psi1 is the first energy level, minus 1, there should be 0 node. And that can be seen by this one, that these all lobes are on the same side. If you talk about the another one, so if you see starting from this particular lobe at the first carbon going through this to the third one, you can see there is 1 node. So according to the formula, node equals to second energy level minus 1 equals to 1 node, and that this particular opposite direction structure tells you that there is 1 node. And for a third one, that is 3 minus 1 equals to 2 nodes. So this is your first node and this is your second node, which is formed in this psi3 star orbital. So this is all about the formation of pi molecular orbital of allyl system, and the allyl system for allyl cation, allyl anion and allyl radical are same, in which there will be presence of 3 molecular orbitals, psi1, psi2 and psi3 star. Psi1 will be your bonding orbital, psi2 will be your non-bonding orbital, and psi3 star will be anti-bonding orbital. So hope this video would have made your concept clear about the allyl system. In the next video we will be discussing about the symmetry present in molecular structures. So up to then, thank you for watching our video and keep sharing our videos, our channel, and don't forget to subscribe it. Thank you.